So one thing, as we start our AP Calc class, Calc physics class, one thing that I want you to see is trigonometry, because trigonometry is unbelievably important, and you're going to see it pop up over and over and over and over again in physics. It is everywhere. We love us some triangles, okay, us physicists. So I wanted to go over a review because it might have been a while since you've seen it, and I know there's a lot of things happening right now, so going over it again, getting a refresher course on it might not be a bad thing. So let's go ahead and start in with it, because you're going to see this pretty quickly in class as soon as we start talking about vectors. So what do we have for trig, right? We've got some basic functions here, okay? We've got so, to, right? And what are those? Well, sine, so this one means sine of some angle theta is what I'm usually going to use as theta. Sine of theta is equal to opposite over hypotenuse. Okay, and let's again remember our parts of a triangle. I don't think you guys probably need to do this, but just in case, the long side is always going to be your hypotenuse. Not HP, but HYP. Why not? Hypotenuse, okay? And the other two change depending on what angle you're talking about. Now, we're going to have a ton of right triangles in here. Not always, but a lot of it will. Okay, so what we're talking about then is this angle or this angle. It's always going to be one of those two. Okay, it's going to be two of the acute angles. So if this is our angle, if this right here is the one we're talking about, that's our theta. Okay, that means the angle, the side that is alongside or adjacent to, because adjacent means alongside. Okay, the side that is adjacent to that angle, that's touching it, is our adjacent side. Okay, and I want you to think about this theta. Okay, think about this as if it's an eyeball. Okay, so there's your eyeball. It's looking out on the world. Okay, so if this is your eyeball, you're looking at things that are opposite you, right? So this side over here is the side your eyeball is looking at. So this has to be your opposite side. Okay, so very important things to start out with. Your hypotenuse is your long side. Opposite is the one that is opposite the angle, the one that the angle is looking at. Adjacent is alongside or touching or adjacent to your angle, okay? Now, what happens in a second example here, let's go ahead and go through this real quick. What if I keep basically the same exact triangle, there's my hypotenuse, but I change it so that my angle is up there? Which one's my adjacent and which one is now my opposite sides? I want you guys to do this. Okay, hopefully this is what you got. So, if this is my eyeball here, which way is it looking? It's looking down here. So this is my opposite side. I'm looking at my opposite. Which one is alongside or touching that angle or adjacent to that angle? My adjacent side. Okay, so it can change. Of the two, this is probably the one we're going to see more often just because it comes up in things like trajectories and all sorts of other things, right? When you're splitting up vectors, you generally have an XY coordinate system, and this is probably the one you use more often. But in any case, we will use both. That's probably going to be the one that you see primarily. Okay, so I'm going to go ahead and get rid of this one. You can always rewind it in the video, which is the beauty of video. Okay, so sine of theta. Okay, so what does so mean? So means sine of that angle. Okay, is equal to the opposite divided by the hypotenuse. Okay, opposite side divided by the hypotenuse side. Okay, what does ka mean? Okay, ka stands for cosine. Cosine of your angle is equal to AH, right? So you're adjacent over your hypotenuse. Okay. What is TOA? The T in that stands for tangent, or tan, okay? Tangent of your angle is equal to the opposite side, okay, divided by your adjacent side. So that's how you can find these things. Now, I want you to see that these things can be worked on very similar to a lot of other mathematical formulas, okay? This is a number over a number, and this is basically a number kind of like times a number. It's not quite the same, it's an operation, but it's pretty close, okay? So you can rearrange these things just like you can with any other equation. So if you've got this, if you're talking about, let's go ahead and grab this tan theta, probably the least likely example we're actually going to use. How about let's do sine. Sine and cosine are going to be our best friends in this class, okay? So if we do sine of theta, that is supposed to be equal to opposite over hypotenuse, okay? And let's say I know this number, it's some number I know, this angle is some number I know, and that's really all I need. I can figure everything out from here, okay? So if that's the case, I know this sine, okay? I know because sine is a function, okay? So I know that theta, because I know theta, I know what sine theta is equal to. I know what my hypotenuse is equal to, but I don't know what my opposite is. So this is my x right here. This is my unknown, my opposite side, okay? So how do we solve for this x or this opposite? We have to do what we would do for any equation. It's on the bottom, so you have to do opposite operation to get rid of it, right? Multiply by hypotenuse, cancels out. What you do to one side, you have to do to the other. Hypotenuse times sine theta will all of a sudden get you your opposite side. And that's it, okay? Same thing is true for cosine. If you wanted to find out your adjacent side, what that value was, right? If this was your x, your unknown, and they both can be, and sometimes they are, you'll have both of these as your unknown. You'll have to do two different operations. For the opposite side, you have to use sine. For the adjacent side, you have to use cosine. And the same thing happens here. So if I do a cosine of theta, I get my adjacent over my hypotenuse. Okay, and if I want to find out what my adjacent side is, what that value is for this guy, again, I have to get rid of my hypotenuse. And what you do to one side, you have to do to the other. So hypotenuse times cosine theta gets you the value for your adjacent side. It's really not that bad. What if you want to find out your angle, though? Let's say you know a couple of sides. Maybe you don't know all three sides, but you know two, and that's good enough, and now you want to find your angle. So you don't know this number, but let's go ahead and assume that you do know your hypotenuse, okay? This one, this is a question mark, and let's go ahead and say you know this number, okay, your opposite side. Well, what two things do we have? We have an angle, so we need some kind of a function of an angle. We're going to decide that in a second. We have our hypotenuse, okay, so we can definitely choose one of the ones that has a hypotenuse in it. So immediately tan comes off our list because we maybe don't know the adjacent side, okay? So that one comes off our list. Our options come down to sine or cosine, okay, because we have the hypotenuse. And we want to find the opposite side. So by process of elimination, cosine goes away and I'm left with sine. I have to use that function. All right, so sine of theta is equal to my opposite over my hypotenuse. And guess what? I know these two numbers, right? So I know this number and I know this number. What I want to find out is my theta. So how in the heck do I do that? Well, this is similar to, but slightly different from rearranging equations, okay? Let me go ahead and do this, and I'm going to back up and show you why, okay? So I have to get the sine off of this side. So how do I do that? I do it by doing the inverse sine, okay? And so I'm going to take the sine off of this side, but what I do to this one, if I do inverse sine, I have to do inverse sine over here. So let me rearrange this. So I'll do sine, and inverse sine is called sine to the negative 1 on a calculator, okay? And that's where you're going to see it is inverse sine, okay? Of opposite side divided by my hypotenuse. And if you do this, if you plug this into a calculator, you'll get your value for theta. You'll get your angle. Be careful. There's two different things on your calculator that you're going to have. There's modes for radians and there's modes for degrees. We're going to use both in this class. First semester, we tend to use degrees and go into radians from there. And radians are pretty much all second semester stuff, especially once we get into rotation. You have to use radians, otherwise things get really jacked up really quick. Or I guess you don't have to, but it becomes way more complicated than it needs to be. Okay, so be careful on your calculators. But this is basically how you do it. If you want to get rid of a sine, you have to take the inverse sine, and what you do to one side, you have to do to the other, so you end up with this formula. What if you had cosine? Okay, what if you wanted to know, what if you knew your adjacent side and you knew your hypotenuse? Well, good grief. Okay, so we'd have to use our cosine function because we know the adjacent and the hypotenuse. It's a process of elimination. You got your hypotenuse, tangent can't be used. You got your adjacent side, sine goes away and it can't be used. So you have to use cosine. And it is your adjacent over your hypotenuse. If we want to get rid of the cosine on this side to find our angle, we have to do inverse cosine, which gets rid of it here. And what you do to one side, you have to do to the other. So I'm going to bump my inverse cosine over for my adjacent divided by my hypotenuse. And voila, you get your theta. Okay? You end up with a nice angle, and you can use that then to find other things like your sine or your tangent. Okay? So that's kind of the opening thing for trig. When do we use it? Well, I've already mentioned some stuff. Vectors are a big one. When we talk about things as a vector, sometimes you only get a magnitude, let's call it 10, and an angle, like let's say 45 degrees, or pi over 4 radians. And then you have to figure out the x component of it, and you have to figure out the y component of it. And this is where trig comes in extremely handy, because if you've got these 3 arrows, there's 3 vectors, 2 of them are unknown, but you know the length or the magnitude of that vector, and you know the angle. So here's what you can do. Here's my vector, 10 with an angle of 45. Okay, I can take the x, and I can draw it right here. And then I can take my y vector, my y component, and I can bring that over to here. So I'm just going to slide the y straight over, and you have to add these vectors head to tail. Okay, so my x plus my y is basically going to be equal, at some angle, to my total vector. My resultant is what they call it sometimes. And they usually use that kind of terminology, R with a hat over it. A hat means it's a vector. Okay, so if I want to find the x component of this, well, what do I have? I have my angle, there's my theta. Here's my resultant, that's my hypotenuse. So this is the side that's touching that angle, okay? So that means it's my adjacent side. So I have my adjacent, my hypotenuse, and my opposite here, okay? So if I want to find x, the x component, what do? Well, I have cosine because I have an angle, okay, it's 45 degrees, right? And I have my hypotenuse, which is 10, that's the value for that. My adjacent is my x, that's the one I wanted to find out. So if I have to solve for x, all I have to do is bump the 10 over. So 10's on the bottom, got to get it off of that side. What you do to one side, you do to the other. So 10 times cosine of 45 will actually get you the x component, or the x vector, for this resultant vector. What about your y? Well, your y is your opposite side, okay? So opposite hypotenuse in my angle, that means I've got to use sine. So I'll get sine of my angle, 45 degrees, is equal to my opposite, which I don't know. We call it y, we call it o. You can write either one down, okay? My opposite side, or my y component, over my hypotenuse, and my hypotenuse is 10, okay? So if I want to figure out the value for y, again, I have to get rid of my 10 off of this side. And what you do to one side, you do to the other. So 10 times sine of 45 will give me my y component. By the way, magic angle, if you have a 45-degree angle, or pi over 4 angle, you will get x and y components having equal magnitudes, or equal lengths to the vector, okay? And remember, magnitude is a scalar, right? And a vector has a direction. So it won't get you the direction, but the direction won't be the same, right? One will be in the x, one will be in the y, but the magnitude of those two vectors will be equal, okay? So that's kind of our intro to trig, and one major way in this class in which we use it. We will use it in others, but this is one of the major ways, okay?